Hello, and welcome to Solutions for Wastewater Pollution, an Ocean Sewage Series video podcast, brought to you by the Reef Resilience Network in partnership with the Nature Conservancy and NOAA's Coral Reef Conservation Program. During the podcast, we will take a deep dive into two of the case studies featured in the Wastewater Pollution Toolkit. The toolkit is a series of web pages featuring the latest science and strategies to help marine managers and practitioners address threats from ocean wastewater pollution. To learn about wastewater pollution challenges in Cambodia and what systems were implemented to address them, Reef Resilience Network Manager Kristen Mays spoke with Dr. Tabor Hand of Wetlands Work, two wastewater pollution case study authors.
Now we will visit Cambodia to learn about HandyPods, a 3-container system designed to capture and treat human waste from floating households or structures. We'll learn about HandyPods from Dr. Tabor Hand, the founder and director of Wetlands Work. Tabor, welcome. Thanks so much for joining us. If you could, please introduce yourself and Wetlands Work and share a little bit about the location of this HandyPods project.
Thank you very much, Kristen. Hello, my name is Tabor Hand. I am the director of Wetlands Work, a very small social enterprise based in Phnom Penh, Cambodia, working on sanitation, innovative sanitation designs, and scale-ups for very poor communities, many of them fishing communities, and places that have not had access to sanitation because of the high water issues.
Tabor, if you could, can you just describe the environment that the project is taking place and tell us a little bit about what that landscape looks like, just for background or context?
Yes, certainly. Let me paint the picture of the landscapes where we are working. The Tonle Sap is the largest lake in Southeast Asia, and it is significantly flood pulsed. The monsoon rains from the Mekong River watershed make the water rise from about 1 meter in depth up to about 8 meters in depth, or up to maybe 28 feet in depth. And this causes a huge inland wetland floodplain zone that the people living in floating houses have to contend with, and they keep moving their houses maybe 8 times a year. And it's a zone where for these floating communities, as well as for the stilted houses in the floodplain, do not have any appropriate sanitation. Pit latrines just don't work. So people have been practicing open water defecation forever, and they have no alternative. And that's where the Wetlands Work HandyPod comes in to provide them an alternative.
Can you talk to us specifically about HandyPods and what specific wastewater pollution issues or challenges the system is trying to address?
Yes. There are 3 particular pollution problems that we are addressing. One is the very, very high pathogen levels of E. coli in the ambient waters of these lakes that cause, for Cambodia, the highest infant mortality rate and the highest child stunting numbers. Every man, woman, and child has a diarrhea event at least once a month. The second pollution issue is that this open water defecation causes very large anoxic or oxygen-free dead zones. And this overwhelms the critical larval fish habitats that are so important for the overall economics of the fisheries. This is also, these dead zones have led to lower aquatic biodiversity and lower fish productivity. So the third pollution issue is that these ambient village waters are significantly odorous. And this is not conducive to favorable ecotourism reviews. and it's not conducive to the government plans for expansion of this sector.
Would you mind explaining to our viewers how HandyPods works?
Yes, the HandyPod is basically three 300-liter, 250-liter containers that water flows through from the pour flush from the toilet pan by gravity into the first container where the sludge tends to build up. And then it moves into the second container as an overflow and has that container and the following container after that, the third container, have significant surface area inside them that are the home for the bacterial biofilm that develops. And this is what is actually breaking down the complex organic molecules and killing out the pathogens largely by competition, some by predation, but it's largely a competition issue of different bacteria and virus and fungi and microalgae that would be growing within this container system. So the discharge that comes out does not have pathogens nearly in the amount. It gets reduced by about 99.99%, or 4 log orders of reduction of the E. coli. And the fecal biomass is contained mainly in the first container and doesn't get out into the waterway to cause the biological oxygen demand problems that we normally have. The first container with a sludge buildup after about 3 to 4 years needs a fecal sludge management protocol, which we've developed that is very, very simple and involves shallow ditches that are about 3 meters long. This is for a single family house, about 3 meters long by 40 centimeters wide and 20 centimeters deep. And then we cover that sludge back over with the soil and leave it for 1 year. And then that sludge is basically cured and is available as a soil supplement for home gardens and such.
Tabor, can you share why this technology is the most appropriate solution for this location?
Yes, certainly. First of all, there's no appropriate and affordable sanitation technology that's been available for high water areas in developing countries anywhere in the world. Wetlands Work HandyPod is low cost. It's between $90 and $150 for a single household. It's very simple. It has no moving parts. It needs no basic maintenance other than the fecal sludge management. All materials in Cambodia and in Myanmar are locally, regionally sourced. And it has a treatment efficiency of about 99.99% removal of the E. coli pathogens. Also, it's very easily replicable by Wetlands Work trained local and independent businesses that we create.
Can you talk a little bit about how the project has gone and highlight some of the successes that you've seen so far?
Yes. For Cambodia's floating villages, we have developed a unique and what appears to be a very successful marketing strategy to introduce sanitation to these very low income, low hygiene awareness remote villages. This has been demonstrated now in 10 floating villages in Cambodia in 2016 and 17. Yet that program did not provide for multi-year support of the local businesses, and these businesses were not sustained. Presently, we are funded for 3 years to promote sanitation awareness and demand in several different Cambodian floating villages with an emphasis on training, professionalizing, and supporting the local businesses over a 2 to 3 year period. This is not a pilot program, rather it is a true scale up for the long term.
Thinking about the network's audience of marine managers and practitioners, what do you consider to be the greatest lesson learned so far through the HandyPod's work?
Yes, the greatest lessons that we've learned are three. One, keep the tech simple with little to no maintenance other than fecal sludge management. Second lesson is base the toilet marketing on aspirational and convenience issues. This generates demand more than talking about health issues. And the third lesson is that households must always pay at least 25% of the cost, even if subsidies for very poor people are available. They must pay something in order to be invested in it, in order for the household to keep the toilet pan clean, to repair the support structure if it gets weakened in a large wave event, storm event, and in doing the 3 to 4 year fecal sludge management protocol. Those are the three main lessons.
Thinking about our marine managers and practitioners who may want to apply this technology in other locations, what social or ecological characteristics do you consider most critical to using or applying this technology somewhere else?
Yes, the locations where the HandyPod is most applicable include floating, flood-prone, high groundwater, clay soils, and mangroves and sandy beach areas. Mangroves tend to have stilted houses. Sandy beach areas might be, say, a tourist site, the bungalows. The most important social elements for the HandyPod are tend to be where people are practicing open defecation or where the pit latrines are inappropriate. And the major sandmark issues or sanitation marketing issues become first community awareness of an alternative, and as well as their willingness to pay for something that has always been free. That's a major behavioral change challenge.
Tabor, do you have any ongoing research that would be useful for our marine managers to hear about?
Yes, we have designed a sanitation treatment system for beach areas and say on tropical islands. And our plan is to design it such that a bungalow, like a guest house or an individual house, would have a HandyPod that is adapted to remove all of the, or 95% of the fertilizing elements in the wastewater discharge, the nitrogen and phosphorus. And we would do that by either adding aeration to blow off the nitrogen with as an N2 gas, or to have it go through a small sort of impoundment or constructed wetland that might only be 3 cubic meters in volume, that is a gravel bed wetland that holds the discharge water and has plants inside the ground growing out of the gravel, and the removal of the phosphorus and the nitrogen from that we would expect to be about 90 to 95% as well. So we think that we can make this so that it is affordable and practical in tropical zones. We want to keep the discharge, especially the nutrient-rich discharge, out of the groundwater and on an island, the water lens, and from going under the beach and into the mid-tide zone area into a seagrass bed or a nearshore coral reef where the epiphytes would be growing because of the nutrients. And this is particularly appropriate for some of the tourist beaches that we find in Cambodia, where we can see that seagrass beds have been diminished significantly, and there's a lot of epiphyte in the coral reefs, largely because of the guest house bungalows and such that they have septic containers, but they don't maintain them, and the wastewater just flows right under the beach and out into the tidal zone. The HandyPod is also very appropriate for the mangrove areas, whether they're mangroves that are going up a estuarine river or on the coastal sort of leeward side of an island. The HandyPod works well in terms of removing the biological oxygen demand and about maybe 20% of the nitrogen. And the pathogens are also diminished significantly. But the constructed wetland for a mangrove stilted house is less appropriate than it would be for the beach side, largely because the mangrove areas are tend to be a little bit lower and more flooded by the tidal zone and the king tides and such. That is our goal, is to move into the tropical island treatment system so that we can have something that supports the seagrass beds and the nearshore coral reef, as well as provides cleaner water for the people who are swimming in the nearshore water.
Well, we're certainly glad to hear that, and the movement from lakes to coasts for the Reef Resilience Network. So, Tabor, thank you so much for your time and for sharing about HandyPods. We really appreciate it. And for everyone else, please visit reefresilience.org to read the HandyPods case study and learn a little bit more. Thank you.
Thank you very much. Appreciate it. Bye-bye.